Hello, welcome to Embedded Systems Practical 8. In our today's practical, we will be dealing with the topic how to design a password operated electronic door lock using a 4 by 4 matrix keypad and a 12-volt solenoid lock. So what I have here is a prototype. These are matrix keypad, some indicator LEDs. Then underneath it we have push button, we have a solenoid lock, electrically operated lock. Then we also have a power supply. Now this is like going to be passed through the door. You understand? For example, now if this is your door, we make an opening, then these are going to be passed through the door, and then from inside the door this will be screwed, so this will be outside of the door. Just like I said, this is also a prototype. You understand? It's a prototype that I have made to show the functioning of a system like this. So let me power it. So here's our 12-volt power source. So I'm going to supply some power to it. So I have power. So this is indicating inside of your door. You want to unlock it from inside. Press this push button. You can see it's going to unlock. After a while it will come back to preserve energy because you're powering this from battery. So pressing this from inside. So from the outside you will need to use a password. So in this case my password is 1 2 3 4 5 6 7 8. So pressing this, you are like clearing the system. Pressing this means that the system is going to reboot. You understand? So let me enter. While I'll enter the password, just take a look at I'm going to enter 1. Oh, let me start all over. So if I press this, it flashes once. That's 2. That's 3. That's 4. That's 5. That's 6. That's 7. That's 8. You can see. So this indicating that the lock is open. Then this LED indicating that the lock is closed. So you see. So you can see. So this will be screwed to the door. So once this is locked, you can open it. So it is electrically, this is a solenoid lock. You understand? So let's go to the block diagram. Let me explain how the system works. So here we have a block diagram. Here is our matrix keypad. This matrix. You remember the matrix we do in school, mathematics. So this here is application. So that's why most of the things you are taught in school, take them serious. They are real. Don't just do matrix so that's to pass mathematics exam. No. Look at the application. So that's what I call this matrix keypad. It's the same arrangement with our computer keyboard. So let's go back to our block. So here's a matrix keypad, our microcontroller. This is a microcontroller I use. This STM32. See, 32-bit microcontroller that I use there. So you can use any microcontroller. Then we have our solenoid driver here. Then we have the solenoid lock. You have already seen the lock. So you can see it's electrical operated. It's 12. We've put in 12 volt in. This is going to go in there. You release the 12 volt, it comes out. So you see. So then your power supply 12 volts from 12 volt power source, could be 12 volt battery or 12 volt adapter. So let's take a look at the wiring. Let's take a look at the circuit diagram. So if you look at this matrix, it's made up of columns and rows. Look at this, the actual keypad that you're seeing here. You can see 1, 2, 3, 4, 4 rows, 1, 2, 3, 4, 4 columns. So these are it is. There are 4 wires. You can look. I mean, there are 8 wires. You look at them: 1, 2, 3, 4, 5, 6, 7, 8. 8 wires coming out of this. Why not? We have 4. This 4 times 4 is 16. Why not 16 wires? It means that we're going to use 16 pins from our microcontroller. How come we have 8 wires instead of 16? So that's where the matrix multiplexing, a technique we call multiplexing, comes in. So instead of 16 wires, we just have 8 wires. How? Let's go back to the diagram. So this is the actual keypad there, the 8 wires that we have there. The first 1, 2, 3, 4, they are the rows, row 1, row 2 to row 4, then column 1 to column 4. So this is the arrangement. So this represents a push button. These are push buttons. We have 4 times 4, that is 16 push buttons. So you see, so these are the 16 push buttons, and we know that this one is number 1, number 2, number 3. Then this is our A, B, C, D. Then we have 4, 5, 6, 7, 8, 9. Here we have 0. Here we have the star, and then we have the hash. So you can see them here: 1, 2, 3, 4, 5, 6, 7, 8, 9. Star, asterisk, 0, and hash, A, B, C, D. So you can see it. So these are they are. So this is row 1, row 2, row 3, row 4, and then we have column 1, column 2, column 3, column 4. So these are it is. If you press this button down, you are short circuiting row 1 and column 1. If you press this button, you are short circuiting column 2 and row 1. If you press this button down, you are short circuiting column 3 and row 1. If you press this button down, you are short circuiting column 4 and row 1. Now, if you press this button down, you are short circuiting column 4 and row 4. If I press this button down, I'm short circuiting column 3 and row 2. If I press this button down, I'm short circuiting column 3 and row 3. So that's how we get 8 wires: 1, 2, 3, 4, 5, 6, 7, 8 instead of 16. This is going to waste pins on your microcontroller, which is not good. So we have just 8 wires instead of 16. So you can see, which means 4 pins, 8 pins. We have saved 8 pins from our microcontroller instead of using 16 pins to control each of these push buttons. So the techniques applied here called multiplexing techniques. Now let's see how it is wired to the microcontroller. Now you can choose any pins. If you look at my STM, you can see the pins numberings as you are seeing it on the diagram. So I decided to use B15, B14, B13, B12 to connect column 1, column 2, column 3, column 4. Then I decided to use B9, B8, B7, B6 to connect my row 1, row 2, row 3, and row 4. Then, this board, this microcontroller here is powered with 3.3 volt, although it has a 5-volt regulator on board. Take note of that. So, oh, I forgot to draw something here. My 5-volt power source solar from 7805. You need to learn how to draw circuit diagrams, very important. So from the 12 volts, we are powering this, all of this with 12 volts. So that's why you're seeing 12 volts there. So here we have 5 volts. So here is ground. Now this is my pin 1, pin 2, and pin 3. I have a protective diode here, polarity protection, 1N4007. Then I have a polarized capacitors at the outputs, and also non-polarized capacitor at the output. And then I have 5.1 volt xenon diode, 5V, and this is 5.1 volt. This is 100 nanofarad, and this is 1000 microfarad, 10 volt. So we are powering this system with 12 volts. So the 12 volt come in here, and then this gives you 5 volts. So the 5 volts, you take it and you apply it to this board here. If you look at it very well, you can see 5 volts. You can also see 3.3 volts. So there is a regulator on board, you understand, that will regulate the voltage from 5 volt to 3.3 volts. So the microcontroller actually is 3.3 volts. So you can see the USB port, you can power it 5 volt, or you can apply 5 volt here. So that's how you get this, you understand. So we are powering this with 12 volts. So from 12 volt you have 5 volts. So this 5 volt you apply it on that 5 volt pin, and the regulator regulates the 3.3 volt and then send it to the microcontroller. So here I have push button. The push button I was pressing there. Then you have some LED indicators. Then this is this one here. The whole of this. So how do we drive this? By using these two transistors connected with this diode. So this is the driver for the solenoid. You can also use this to drive relay also. So you can still call this a relay driver or motor driver. So I'm using this pin for controlling this. So you can see, so what we have here is digital input. We also have here digital input. Then we also have here digital output. So everything here is digital. You understand? So how will the microcontroller know that I press number 1? Now this is what happens. Now I'm supposed to connect some resistors this way. Connect 4 resistors here, but I don't need it. This microcontroller have something we call pull-up resistors on each pins. So what I will do, at a particular time, I will set some of these pins as input or output. You understand? So what I'm going to do, these rows, I'm going to set them to be input. To input pull-up. You understand? Then I will set some of this one as output. So by the time I press, I'm going to send these pins output and make them low. So by the time I press this button, this pin, they are not going to go low all at once, one after the other, but very, very fast. It will send this one low and then check the pins. That is, I will turn these pins, for example now, these rows now, I'm going to make them as input. You understand? I'm going to make them as input pull-up. Then one after a time, I'm going to set each of these ones as output and make them low. So for example, now I start with this now, the microcontroller, I'm going to make this pin low. And when this pin is low, if I press this button, it is going to detect low on this pin. So it's going to know that I press number 1. By the time it releases this, then to set this pin low again. So if I press any of these columns here, if I press this one, it will going to detect low on this. It will know that it is D I press. So it does that very, very fast. So anyone you press it, to quickly detect it. So that's how it works. You understand? So that's how it can be able to detect any key that I press. Then the program is what does the magic. The software, the programming part there, that's where the whole magic happens. So it will detect and be able to know which particular key I press. Then as I'm pressing these things, I'm going to be like storing them in an array. You understand? For example, if I press 1, it will going to hold 1. If I press 2, it's going to hold it. If I press 3, it's going to hold it. So my password is 8 digits. So I'll make sure these things, once it reaches 8, it has overflowed. So understand? So once it reaches 8, then to check against the stored, like my password here is 1 2 3 4 5 6 7 8. So any digit I'm pressing here, once they complete 8, it will compare it with the password, with the reference password I put in the program. If it is the same thing, then it's going to send digital signal to this transistor. The transistor will send signal to this, and the solenoid. This is going to pull inside. Now this is the lock. Like this one that you are seeing here, you can see it like this. So once it is electrified, it's going to go in this way. So you can see. Then it will stay, instead of staying there, you're going to be wasting power, electricity. So it will go in there, allowing you now to open the door. You understand? So when you open the door, you can close the door back. When you enter inside, how do you open this when you are inside the house? There is a button in here. So that's why I put this push button. So inside of the house, each time you want to open, you press it and the lock opens. So you see, which is the push button that you are seeing here. You understand? So that is how this system works. Now the same system is the same thing on our computer keyboard. Like if you check this keyboard, there are over 100 keys. There are over 100 keys. So I don't think the microcontroller in here have up to 100 pins, but they multiplex them. They use the method of matrix to arrange all these keys. You understand? So the same way, the principle they applied here. So the same thing on our phone, on our button phones. The same thing we have on these remote controls. They are also matrixed. Don't think the microcontroller have pins that will match all these buttons here. All these are push buttons. The same push button that we have here. They are also multiplex. So these are also arranged in matrix format. You understand? So that's how the system works. Let me power it so that we see it again. So here I'm applying 5 volts. So the system is, so if you look at this, just take a look at this. I'm inside the room now. If I press this, you see this LED, this means that it is closed. So you see each time you can see indicating that the lock is open. After some seconds it will close. By then you're out. So you can see. So this, you are outside the door. You're going to enter 1 2 3 4 5 6 7 8. So if you mistakenly like press this in more than once, you can just press this C. It will clear and then you come in again. 1 2 3 4 5 6 7 8. You can see. So that is how it works. So you can come in. Now if this LED flashes this, you can just simply clear this for you to start from 0 and counting. press the 1, 2, 3, 4, 5, 6, 7. If we have pressed this more than once, you can just simply clear this again. Let me hold this. 1, 2, 3, 4, 5, 6, 7, 8. So you can see. So that's how it works. So 1, 2, 3, 4, 5, 6, 7, 8. It will. Now each press you press here, if this LED flash like this, it means you'll have to press the C. So each press, the LED will flash once. So if you press and the LED behaves like this, you have to clear it and restart all over again. If you press this, you clear, so you come in again. 1, it has to blink once. 2, 3, 4, 5, 6, 7. You can see. So that's how it works. So you know, from inside, if you press this button, if you look at the lock, it's going to, you can see it. So you see, press this button from inside. So you can see. So that's how the system works. You see, 1. If this is flash, you can just cancel. 1, 2, 3, 4, 5, 6, 7. So you see, so that's how it works. You know, this keyboard is a flexible keyboard. You can fold it. This is flexible, so it's flexible keyboard, and this plastic is also. So you see, so that's how the system works. You understand? So that's how the system works. Making electronic lock. Making electronic lock with this. So you see it. So this 12 volt. We also had one of 24 volt. We also had one of 9 volt. We also had one of 5 volt. We also had one of 6 volt. So you can see it is even 1. So the reason why I have to make it this way is that if this thing is energized and you keep it continuously being energized, you're going to be wasting energy, electrical energy, and which is also going to heat up this. So you don't need to hold it that way. So after opening, you might have opened the door, the lock should be released so as to not to waste energy. So you understand? So each time we complete our password, so you can see, so it will stay on for just some seconds, and then you can see, so that you don't waste energy. So I believe you've understood the system. Now if you are going to make this in real life, you will not use this type of this thing. You're also not going to use something like this. You make sure you use something that it cannot be opened from outside. Everything has to be metal. But this is just a prototype. You understand? It's just a prototype for demonstrating how such kind of system can be designed. So you can see, so the system is functioning exactly how I've programmed it. Now the software running in here, I wrote it in Arduino C programming language. You understand? I wrote it in Arduino. Now take note, this is not Arduino board. This is not an Arduino board. It's not from Arduino company. This is STM32 from ST Microelectronics. You understand? So for you to be able to program this from using your Arduino programming language, you need to install the plugins for this. You need to install the plugins so that you can be able to program this. You understand? Like these boards that you have here, this also not from Arduino. This LGT, this ESP8266, this ESP32. But I program all this from Arduino using the Arduino IDE and Arduino C programming language. None of these are Arduino boards, so take note of that. Although you can use any microcontroller to do it, depending on your understanding of the microcontroller that I use. I understand this microcontroller very well, so that's why I use them. So you that you don't know anything concerning this, use the microcontroller you know how to use. For example, if you're only familiar with the Arduino and Nano and the Arduino Uno, you can still use them. Now this one I did not how did I now if you are using Arduino boards for this, there is a library. The Arduino already have a library already, but the library doesn't work with this. You understand? So I made my own library that is working with it. I created my own library myself. So I created a library that is working with this. The Arduino library, the Keypad library doesn't work. The Keypad library, we have Keypad library. If you are using Arduino Uno Mega, you can use the Keypad library. But for this STM32, it doesn't work. I tried it doesn't work with this, so I have to figure out way of doing this. You understand? So so that's how this works. So take a look at the circuit very well, and you can go and try it yourself. You can go and make something. So think of how you're going to make this thing, something like this. If you're making, you'll make it, let it be metallic, such that it cannot be opened from the outside. Make sure everything is from the back. And if it is the idea of this is that if this is the door, I'm going to make an opening, and then I'll pass all this through the door, and from inside the door everything is going to be screwed in. That is just the idea. So the prototype is working the way we designed it. You understand? So if you benefit from this video, please like it and share it, and go and try out something yourself. Don't just go and sit down, and you electronics engineering student, you computer engineering student, just go and sit down, try something. Practice. The more you practice, the more you get knowledge of this. You understand? Like you that you are just watching, you were not going to get this knowledge of this practical knowledge until you go and try it. It is when you try something, experience comes. You don't get experience by just watching videos or just reading books and not doing anything. No. Like, how did I learn all this? I have to read from the internet, study a lot of things, and then try something myself and put up something myself. So you see, so go and try this. Go and try this yourself. So see you in our next video. Goodbye.